Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the chain rule in computing the derivative of this given composite function. Yes, you heard it right. This function here can be expressed as a composite function. Let us say our h of x is x to the power of 7, and then our g of x is identified as x cubed minus 4x squared plus 5x minus 10. So you can rewrite this as h of, or your f of x, okay, is a composite function h of g, sorry for that, let me have this notation, h of g of x being this form here, okay, because you are substituting this entire g of x to your x of our h of x, then you will have again the 7 of x cubed minus 4x squared plus 5x and then minus 10. So this follows the criteria for a composite function. Hence, we are going to use here the chain rule, which is the rule in differentiating a composite function. For f, or let's say h here, for h of g of x, okay, its derivative h of g prime of x follows this formula for the chain rule. You take the derivative of the entire expression, treating this as one entity, probably using here the rule of differentiating a power, and then times the derivative of this expression here inside. And this is actually what is equal to h prime of f, rather, as the given here is expressed in terms of f of x. So before we start, you can of course have your scratch here, as you will try to solve first this components before you can multiply them. So for this, again, treating this as 1, so you will have to use here the power. So the rule of differentiating a power, you will have your n, or 7, times, you have this, treating that as 1, x cubed minus 4x squared plus 5x minus 10, and then you have your n minus 1, where your n is 7. Hence, you will have here 7x cubed times x cubed minus 4x squared plus 5x minus 10 raised to the power of 6. Do not distribute that or multiply that to all the terms inside, because this has an exponentiation, and if we would like to really simplify that, we will be using exponentiation first, which would take a lot of time before multiplying 7. Then this next component, g prime of x, this was our g earlier, which is just similar to that. So just use your rules of sum and all other rest. So you will have here x cubed, that's 3 n x n minus 1, okay, that's power, minus constant multiple 4 times 2 x to the power of 2 minus 1 plus 5 x to the power of 1 minus 1, because that has an exponent of 1, minus 0, as 0 is a derivative of a constant, negative 10. Therefore, your g prime of x is 3 x squared minus 8 x plus 5 x to the power of 0, or again, that's just simply equal to 1, so we will have here plus 5. So once we are able to finalize this, let's go back again to the intended goal. This is for a derivative of our f of x, which is again a composite function. So you're going to use here this formula for the chain rule. Take note, I am using here h and g, might be different to the previously proven or illustrated rule, because I have here f. I cannot repeat f on the same formula. So this is again the product of 7 times x cubed minus 4x squared plus 5x minus 10, that is all raised to 6 here, times your g of x, which is 3x squared minus 8x plus 5. Pardon for the space. Now for the final form, simply you can just rearrange it this here. So 7 times x, 3x squared rather, minus 8x plus 5 times x cubed minus 4x squared plus 5x minus 10 raised to 6. Now others would still like to multiply that. You may, if you can, but just for me, this is already okay, since I can still no longer multiply whatever the result here to here because I have an exponent of 6. So better yet, stick to this as our final answer for a derivative of this given composite function. Take note of the formula for the chain rule or the rule in differentiating a composite function. Thank you very much for watching. So what are you waiting for? Subscribe now!